Welcome back, everybody. So, this time, before we move to the actual story, I've got to tell you a backstory. As you all know, we were all put in the lockdown in the past few months because of the pandemic. Then, my routine was to sit in the house, munch everything edible, and be absolutely jobless. But, being jobless has given rise to a lot of weird ideas, and one of it is this glove. This gloves. Can you imagine a glove that can take you to any place and any time? Well, this is it. Basically a time machine that can also teleport you at the same time. This time, I'm going to use this glove to tell you a story.
Welcome back, Newbridge. Where would you like me to take you this time?
A nice, flat, plain surface on Mars.
Interesting choice. Which date?
10/11/1972.
Time?
Nothing specific.
Hold tight and here we go. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and off we go.
The day when a massive sandstorm was making its way across the tiny red planet of Mars. A refrigerator-sized spacecraft was orbiting the planet. It was here on the mission of mapping the surface details of Mars, but the storm was making it impossible. Scientists who were looking at the footage from this craft started kidding that we accidentally went to Venus instead of Mars. Addressed as the Mariner 9, the spacecraft was patiently orbiting Mars, waiting for the storm to settle. The scientists chose this date because Mars was the closest to Earth in 16 years, but the storm was unexpected. They had no option but to wait and let the vehicle orbit the planet. As it did, it saw a small part of the Martian surface peep out of the stratosphere, till which the storm was blowing. What they stumbled upon was the solar system's largest volcano and the largest mountain. The peeping Martian surface was the summit of the mighty volcano, the Olympus Mons. It covers an area of about 30,000 square kilometers, as large as the Indian state of Rajasthan, and rises 21 kilometers in the air, about 2.5 times that of Mount Everest. More than the volcano, the discovery triggered several chain reactions. Till this discovery, scientists considered Mars to be a mere rock captured by the sun's gravity. The Olympus Mons was the first volcano to be discovered on Mars. This proved the existence of volcanism in Mars. Thus, it was proven to be a planet. The Mariner 9 spacecraft discovered 3 other volcanoes in about a 1,000-kilometer range from this mighty one. This region was known as the Triasis. Even the smallest mountains here are larger than the Mount Everest. Why are Martian volcanoes exponentially larger than Earth's? How are they different? Scientists have discovered 3 major factors that cause this difference. 1. Lesser gravity. Most of you must be aware that when we go to space, our body will drastically start losing weight. This is because the gravity in space is lesser than that on Earth's. So the burden on our body of holding our weight is reduced. Our bodies respond to this change by drastically disposing calcium and proteins, whose jobs are no longer needed. This causes drastic weight loss. Something very similar to this happens on Mars. The gravity on Mars is about 3 times lesser than that on Earth, so the burden on the Martian mountains of carrying themselves is lesser. This allows them to grow taller with a less fear of collapsing on themselves. 2. Stationary tectonic plates. The Earth's crust is divided into 7 major chunks known as the tectonic plates. This includes the seabeds, the riverbeds, and the continents. These plates on Earth are always on the move. This is not the case on Mars. To really understand how this difference plays a part in the larger size of volcanoes, I have made a simple representation of the mighty process of a volcano formation. The Earth is divided into 3 major layers: the crust, mantle, and the core. The core is made up of hot boiling liquid rock and is as hot as the surface of the sun. This heat melts the weaker portions in the mantle. This molten rock is lighter than that in the surroundings. So it rises up to the edge of the mantle. The weak portions of the crust give way to this and cause what is termed as a hotspot. These weaker portions are usually situated where two tectonic plates meet. Hotspots are vents on the surface of the earth where eruptions occur. When an eruption occurs, the molten rock from the mantle bursts its way through the crust and comes to the surface of the earth. Till now, the molten rock is addressed as magma, and once it's on the surface, it is called lava. This lava cools to form rocks that accumulate to form a mountain. Then tectonic plates move, so a new chunk of crust is on the hotspot. So after a few eruptions on this new piece of land, another mountain forms. This process goes on and on and on, forming several volcanoes on our planet. This is how the famous Hawaiian Islands, the Indonesian islands, and the islands that constitute the islands of Japan formed. This is the reason why these areas are extremely volcanic. On the other hand, tectonic plates on Mars are stationary, so the hotspot and the volcano are fixed. The lava piles up eruption after eruption, causing these giants to form. Had Earth possessed stationary tectonic plates, then the volcanic islands like the Hawaiian Islands would have been a large volcanic mountain instead of a chain of islands. 3. Higher eruption rates. The number of eruptions and the amount of lava that comes out in an eruption are comparatively higher in Mars. The key factors for this difference are the viscosity and acidity of the lava in different types of volcanoes. Apart from these differences, the Hawaiian volcanoes and the Olympus Mons and its neighbors in the Triasis region are very similar. Both these regions consist of shield volcanoes. Now, what is a shield volcano? Volcanoes have been divided into 5 major types. The Olympus Mons is a mixture of the first and the third type. It is a shield volcano with an impact crater termed as the caldera on its peak. The opposite kind to this is a stratovolcano. Let's look at each of these one by one. First, shield volcanoes. We always tend to think of volcanoes as mountains that spit a large amount of molten rocks, lava and gases through violent eruptions. But a shield volcano is not of that kind. These mountains are shaped like a warrior shield, and its eruptions are very similar to the overflowing of milk. As the pressure and heat increases inside, the hot molten lava slowly starts to flow out of the vents. The lava from shield volcanoes are usually viscous and are not acidic, so it has a longer time to retain its liquidity. This enables the lava to spread over a larger area. Mount Mauna Loa is the largest shield volcano on Earth, and the Olympus Mons is the largest in the solar system. Shield volcanoes have disturbed a lot of human settlements over the ages, but these eruptions are easy to predict, so it gives us ample time to relocate to a safer place before the eruption. The Hawaiian Islands on Earth and the volcanoes in the Triasis region on Mars are made up of shield volcanoes. Some volcanoes in the Hawaiian Islands are still very active, but there have been no notable eruptions in the Triasis region since events came to be recorded. There have been a few tiny lava leaks recorded over the years, so if you end up on Mars, think twice before you climb the Olympus Mons. Next, stratovolcanoes. These are those famous violent volcanoes. These mountains are tall and steep. The eruptions are sudden and violent. Their eruptions are mainly made up of dust, hot ash, and rock powder. In very rare cases, lava erupts from these mountains. The magnitude and destruction of these volcanoes are comparatively much higher compared to shield volcanoes. Large clouds of dust, ash, and hot rock rises in the air and slither through the sides of the mountains. These are known as pyroclastic flows. These flows can move up to 100 kilometers per hour and burn everything on its way. These flows are usually associated with stratovolcanoes. The actual eruption and the intensity of these eruptions are very tough to predict in a stratovolcano, so they have claimed the lives of millions of humans through the ages. The most intense destructive eruptions known to humans are that of stratovolcanoes. The eruption of Mount Tambora is a perfect example for this. It erupted in the year 1961. The eruption triggered high tsunamis and violent earthquakes that cost the lives of thousands of Indonesians. The eruption was so intense that it blew one half of the mountain, causing the 13,000 feet high mountain to become a 3,500 feet deep caldera. Here is a model prepared by us to demonstrate its working. Last but not the least, calderas. A caldera is a depression formed on top of a volcano. These form both in shield and stratovolcanoes and are created in two ways. In some cases, the eruption is so violent that it blows the top of the volcano, forming a depression. This is a very violent way of caldera formation. The already mentioned Mount Tambora is a perfect example for this. In most cases, a collapsed caldera forms when the hotspot loses its pressure, or it dies out and the lava is drawn out. To understand this process better, let us do a simple experiment. I have this ball, it represents the hotspot. I am going to bury this now. Now, I remove the air out of it. The air represents the magma in the hotspot. This is what happens when a hotspot loses pressure, dies or moves. Once the matter moves from the inside of a volcano, the ground pulls due to gravity, causing this depression. This is how the collapsed calderas form. Scientists have also predicted the story behind the formation of the caldera on top of the Olympus Mons. They say that the hotspot under this mountain lost pressure. It appears to have died out, causing this depression. After studying about these, my imagination of Martian volcanoes, especially the Olympus Mons, became clearer. Till then, the measurements of the Olympus Mons were just numbers to me. But then they became comparative scales on my imaginary image. This raised another important question. How could a volcano massive in size, rich in geology, and a major spot on the Martian surface take so long to be discovered? It took me a while to find the answer, but it was equally interesting as the question. November 10, 1972 was the date when the modern and technologically advanced humans discovered the existence of such a volcano on Mars. But humanity has known about this from much earlier. This can be traced to the early Greek civilization about 200 BC. The Greeks believed the great mountain of Olympus on Mars was the home to their gods. They also believed in life after death, so they say that after death, humans go to the Olympus. If we send her over to Olympus Mons, we would be able to give the Greek ancestors a fun ride. While reading about this mountain in a bit more detailed manner, I stumbled upon some super awesome information which evidenced that life existed on Mars. Scientists say that about 4 billion years ago, the Triassic region was just like today's Hawaii. It was a region consisting of active shield volcanoes. Some soil samples from this region reveal the traces of the presence of water in the past. If this was true, then the Triassic region was surrounded by water, so it would have looked just like the Hawaiian chain of islands. These are some hypotheses that suggest that Mars could have had been like Earth in the past. To really know more about this, we have to study from the formation of this red planet, which I am yet to do. I hope this will be the subject for one of my future videos. Most of what we have seen till now suggests that the Olympus Mons is very unlikely to erupt. There have been a few lava leaks since eruptions came to be recorded, so watch out if you get to climb this mountain one day. Never forget to take a raincoat and an umbrella.